Do you know what database keys are? Do you know the difference between primary key and foreign key? Do you know what's a surrogate key or a natural key or a superkey? There are so many different kinds of keys in databases, and it can be confusing and intimidating to understand the differences between them. So if you're curious what all these keys mean, let's see it together in this video. Hello and welcome. My name is Elhelw, and today we are going to be talking about database keys. Like I mentioned in the beginning, there are so many different kinds of keys, and the concept of keys in databases, or specifically in relational databases, is super important. The terminology can be a little bit overwhelming sometimes because of the sheer number of different key types that are there. So, for example, there is a primary key, there is a candidate key, there is super key, there's also alternate key, there's foreign key, natural key, surrogate key, simple key, and composite key. So all these different keys are there. One key may actually belong to many of these categories at the same time. So these are not exclusive, but you can see how confusing this can get. So let's try to clear up the confusion and demystify what keys are. So to do that, let's start with an example. Suppose we have this table that represents employees in a company. So each row represents one employee. We have the employee name, the department where they work, their social security number. This is a unique identifier that each employee or each person in the country actually has, their email, their phone number, and their salary. Now, suppose that we have a question like, find the salary of Bob. So I want to be able to find the salary of this employee called Bob. The problem is, with the data that we have here, we don't know which Bob we're talking about. There are two Bobs. So just the name is not sufficient to identify which employee we are talking about. Someone may say, okay, well, let's say Bob who works in sales. So this, use the employee and the department together to identify that employee we're looking for. In this case, that works because the two Bobs that we have, one works in sales, one works in engineering. So if we say Bob in sales, then this will help. So this gets us to the definition of a key. What is a key? A key is basically one or more attributes that help us to uniquely identify a single row or tuple in the data. So if we want to find or update a specific tuple, we want to have one or more attributes that will get us to where the tuple is or which tuple that is. So a key may have one attribute or it may have multiple attributes. If it has one attribute, it's called a simple key. If it has multiple attributes, it's called a composite key. So let's look at our example again and see what different attributes or combination of attributes may or may not be keys based on the definition that we've just seen. So let's look at the name. Is the name attribute good as a key? Does the name uniquely identify a tuple? No, we have duplicates. We have multiple Bobs, we have multiple Alices, so the name by itself is not a key. All right, let's look at the department. Is that sufficient? The department by itself, obviously also not, because we have duplicates. There are multiple employees working in each department. So if you say sales, you don't know which row that is. There are multiple employees in sales. So again, department is not a key. What about the name and department combination? In this data right here, the combination of name and department seems to be unique. There are no two employees within the same department who happen to have the same name. So if we combine the name and department, that should give us a unique row. However, even though this is unique for the data that we have here, this might not always be unique. Suppose that tomorrow a new employee joins the sales department and this employee also happens to be called Bob. So then we will have two Bobs in the sales department. So then it will not be unique anymore. So when we're talking about uniqueness, we're not talking only about the data that we have today, but we're talking about something that will also be true in the future. So as a result, name and department, it might be true now, but in the future it might not. So it's not guaranteed to be unique. So it's not a key. What about name and social security number? Social security number is a unique number that each person has. No two people have the same social security number. So even if the name is repeated, the social security number combining that with the name will be unique. So this combination is unique and it can be considered a key. What about the social security number by itself, without the name? Like I just said, this is a unique number, so no two people have the same social security number, therefore it can uniquely identify a row. Let's look at email. Email is very similar. No two people have the same email. Again, this is a unique thing that every person has. So this can also be considered as a key. What about the combination of social security number and email? Well, each of them is unique by itself, so the combination has to also be unique, right? So this is also a potential key. What about name, department, and email? We saw at the top name and department alone might not be a key, but if we add email to that, since email is unique, then this whole combination becomes unique combination for each row. So no two rows will ever have that same combination of attributes, so this could also work as a key. What about the phone number? Phone number, as we can see here in the data, this is not unique at all, so it's not going to work as a key by itself. But what about email and phone? So phone is not unique, but once we combine it with the email, then it becomes unique. So those two together can work as a key. Of course, there are also different other combinations that we didn't consider, like, there could be, I don't know, email and name and phone, or like, phone and department and social security number. There's like, a whole bunch of other combinations. So this is just a sample. So the ones that we have marked with the green check mark, like the ones that can work as a key, these are referred to as superkeys. Each superkey basically is a set of one or more attributes that can uniquely identify a row in the table. And like I said, there might be more superkeys than the ones that I've listed here. Also, yeah, if a superkey has a single attribute, like social security number or email, this is called a simple superkey. If it has multiple attributes, like name and social security number, this is a composite superkey. So again, anything with single or multiple is either a simple key or composite key. Super keys are not something that's used in practice. This is something that you would find in the literature, in books, but this is not something that you would find when you're designing an actual database. But it's kind of like it's the basis where other keys are defined later on. So it's important to understand what that means in case you're reading in the literature. Then if you see super key, then you know what super key is referring to. Why isn't that used in practice? Because super keys, as we can see here, they may actually contain additional information or additional attributes that we don't actually need. And this additional information or additional attributes may actually cause problems. Let's see an example about that. So here's our table, and one of the super keys that we have seen was the social security number and email. So this combination, we said this is unique for each row. No two rows will ever have this combination, right? So let's say I want to add another row. So I'm going to add this row here. If you look at the SSN and email combination, it's unique. No other row has this combination ever, so this is correct. However, if we look at the email alone, the email is actually duplicated. So we made sure that the combination of social security number and email is unique, but each one of them now may be not unique, and it will still satisfy the super key property. Why did that happen? It happened because this super key is what we call, it's not minimal. It can be reduced. It has extra information or extra attributes. Let's look at the definition of that. Suppose this is a super key. It has attribute 1, attribute 2, attribute 3. It's a super key. It means that this combination of attributes is unique for every row. Now, suppose that we have another super key that consists only of attributes 1 and 2. This means that attributes 1 and 2 together are sufficient to uniquely identify a row. So since that is subset of the original one, this means that the original one has some extraneous information. So it is not a minimal superkey. So a minimal superkey means that I could never find a smaller superkey, like a subset of the attributes in the superkey, that can also be a superkey. So if we look at the superkeys that we have found earlier, let's say the first one, name and SSN. This is a superkey, correct. But is it minimal or not? Since the next one, which is social security number, by itself is a superkey, this means that social security number is sufficient to uniquely identify a row. So adding anything to that becomes extraneous. So adding name to that means that the first one is not minimal. The second one, since it has just one attribute, cannot be reduced further. This is minimal. Email by itself is also minimal. Social security number and email together well, each of them is minimal, right? Each of them is a super key. So adding them together means that there's extraneous information. So again, this is not minimal. Anything that has email or has social security number plus additional attributes is not minimal. So the only minimal super keys in this case are the social security number by itself or email by itself. The minimal super keys are referred to as candidate keys. So a candidate key is a minimal super key, as we've just seen. It is unique for every row, so no two rows will ever have the same value for the candidate key. The candidate key can also be simple or composite, so either one attribute or multiple attributes. And knowing what the candidate keys are, this is the first step to come up with the primary key. Of course, we have heard about primary key or we're familiar with that, but this is where it comes from. So we need to identify the candidate keys, and then from that, we can select the primary key. Looking at our example again, these are the two candidate keys that we have found, either social security number or email. Which of these do we select to be the primary key? Let's talk about the first one, the SSN. So SSN is a unique number for every person. This is something that is also used outside of the database. So people would use that in, let's say, in their communication with their bank, or like, whenever they apply for something, or when they're doing their taxes and so on. So they're using this social security number in multiple places. So it's something that they're familiar with, they can use, they can easily remember. So this is a potentially good primary key. It also doesn't change. Once a person has a social security number, it will never change. So that's something that's also desirable in a primary key. The only downside for social security number in particular is that it may have some privacy constraints. Maybe you don't want to overuse it or use it as a way to refer to things or to log into the company website or something like that. So maybe it's not a great idea to use it. But if that constraint was not there, this could be a good primary key. Email is also a good primary key. It's unique for every person. No two people ever have the same email. For the employees in the company, we know that every employee has an email, so this will never be null, for example. Also, obviously, this is something that people know and remember. The only downside potentially is if people change their email address, right? Someone may come tomorrow and say, hey, I don't want to use this email address anymore. I want to use this new one. So when we're talking about primary keys, we usually try to look for something that does not change or does not change frequently, at least, because changing it is super expensive, since this is the primary means in which I'm going to use to refer to this employee. So this means that this is going to be mentioned in several places. So if I change this, I have to change all the references to it as well. So we try to look for something that will not change. But if we make a restriction, as you've probably seen in some websites where you cannot change your email address, for example, then this would be a good primary key. In our case, we're going to choose the email as primary key in this case. So once we've chosen that, any other candidate key that has not been chosen as a primary key is referred to as an alternate key. A table may have only one primary key, but it can have multiple alternate keys. So again, just something to keep in mind. What's a common example of a primary key? When you log into a website or when you sign up for some website and you specify a username, right? Usually when you are signing up and you type in the username, you might get an error saying like this username is already taken, right? So basically what this is telling you is that it's looking for a unique value. So each user needs a unique username. Also, once you've signed up, oftentimes you cannot change your username anymore. So this is, again, the primary key requirements. That's something that does not change. So it's unique and it does not change. So this means that most likely they're using this username as the primary key. So if we look at the primary key properties, as we've said, this is one of the candidate keys. This is unique for every row in the table. It cannot be null, so no user will ever have a null username, for example. No employee will have a null email or like empty email or empty social security number. So it cannot be null. It is also stable, something that does not change or does not change frequently at least. It can also be simple or composite. So if it's a single attribute, then it's simple. If it's multiple attributes, then it's a composite primary key. And as we said, any candidate key that was not chosen as the primary key is called an alternate key. All right, even though we've chosen email, let's just take a step back and let's assume that we haven't chosen the primary key yet. We still have those two candidate keys, but let's say we're going to take a different route. I'm going to add another column to this table, call it ID, and I will add some arbitrary unique numbers in there. So for each row, I will add a unique value. Since this is unique and since it's not null, it can be identifying for every row because no two rows will ever have that same value. So this is a candidate key. Now I want to choose one of those three as the primary key, right? There is a difference between the two candidate keys that we had and the new one that we just added. The first two are called natural keys. Natural keys are keys that have meaning outside the database. For example, social security number, like we said, this is something that is used outside. It's used in, in a person's taxes, in their banking information, in multiple other places. So this is something that has real meaning outside the database. The same thing with the email. Email also has meaning outside the database. People associate that email with the person. They know when you tell them that email, they know that, okay, this is John's email, this is Bob's email. So this is something that's associated with this entity outside of the database. The ID field is called a surrogate key. This is something that does not have meaning outside the database. It's something that we just added to represent these rows. But outside of this, it doesn't really mean anything. Nobody outside the database will know that John is associated with the value 4. It doesn't mean anything. But this is something that we use internally to potentially become the primary key of this table. So which one should we use? Should we use a natural key or a surrogate key as the primary key? Usually, you look at your entities first. Does the entity have something that could work as a natural key or not? Examples of that would be email, social security number, username, airport code, stuff like that. So things that have meaning outside and also have the properties of a primary key, meaning that they are unique, that every row has them, and that they're stable. If you have something that satisfies these and it's also a natural key, then perhaps it's good to use that. If you don't have something like that, then you will need to create a new surrogate key and use that as your primary key. What's an example of that? Let's say you have a table for teams within a company. So each team, you want to put the team information in that table, but the team doesn't have any natural key associated with it. So you're going to add a team ID column, for example, and each team will have an ID. And then this will be the primary key. One thing to note, if you start using that team ID in like outside the database, you start using it in communication, you start referring to these teams by ID when you're talking to people, then sometimes it can stop becoming a surrogate key and it becomes a natural key once it has meaning now outside the database and people are referring to, team S or team, whatever IDs that you're giving to the teams, then it becomes a natural key. Sometimes you may have a natural key, but you cannot use it as a primary key. For example, the social security number, as we mentioned. If you have some constraints about it that you are not able to use it for referencing entities and so on, for privacy reasons, for example, then you cannot use it. You may have to have a surrogate key in that case. All right, let's see how this is done in Postgres. So I have this employee table here. It has these columns: ID, name, department, social security number, and salary. So far, I haven't defined any keys on that table, so we'll do that as we go. Let's look at the data. So let's start from employee. This is the data that we have. We have 6 different employees, and this is their data. Let's say that I want to try to define a primary key. And just for the sake of the experiment, let's say I want the name column to be the primary key. We said that this is definitely not a great idea, but let's see, can that work? Given that we already have some duplicates here. We have Bob repeated twice, and we have Alice also repeated twice. So if I try to say alter table employee, add primary key on column name, this is the syntax that we use. So of course it's not going to work. So it gave me an error, could not create this unique index primary key. And the reason is because name Bob is duplicated. So as long as we have any duplicates in that column, you cannot make it a primary key, which is expected. So let's do the right thing, and let's say the ID column is going to be the primary key. So that one was successful. So let's look at the table definition again. Now we can see that we have a primary key on ID. So what does that help with? If we try to add another employee, let's say Tom, and I'm going to use one of the existing IDs. So let's say I want to insert this Tom employee with an ID equals 5. So 5 is already in the table. So this should not work because of the primary key, obviously. Now that I have this primary key, I cannot have two rows with the same primary key value. So, okay, so let's change that to 7, since we have already 6 employees. So now this insertion has been successful because it's a new ID value. Let's look at the contents of the table again. So now we have these 7 employees. I did a purposefully not correct thing, which was I added this new employee with the same social security number as Alice, employee number 6. I don't have any constraints on this column, right? So technically it's allowed, but we know that social security number should be a unique value per person. So no two people should have the same value, but the database did not prevent that from happening. The way I could prevent this from happening is by defining a unique constraints on the social security number column, even though it's not the primary key. So the way to define that would be, again, using the alter table statement. So saying alter table employee, add unique on this column. Again, this is not going to work right now because the data is already wrong and would not satisfy this constraint. So I need to fix the data first before I can add that constraint. So it says here the error because SSN equals 384 is duplicated. So I'm going to remove that row that we just added. So now I've removed that and I can add the constraint, and now it's successful. So again, let's look at the table definition to see what that looks like. So now we have the primary key on ID as we've had before, and now we have a unique constraint on social security number. So these are the two constraints that we have. To confirm, if I try to reinsert that row that I just deleted, the one that had the duplicate, now it will not allow me to insert it because it will say that this value already exists and violate that unique constraint. So this is how we can use primary key and unique constraints to make sure that values are unique. All right, so let's get back to our example. This is our employees table again, and suppose that we're going to use the ID here as the primary key. So whenever I need to refer to any employee, I'm going to refer to them by their ID. Now, suppose that our database has a new table for projects. Each project has 2 attributes, just the project name and the project lead. The project lead is the person leading that project. So the project lead has to be one of the employees, right? So since we're referring to employees by their ID, we're going to use the IDs here in this table. So project 1 is being led by employee number 4, which is John. Let's say a new project comes in and I want to enter the data, so I'm going to add another row in the project table. I'm going to say project 4 is led by number 8. There is a problem here that 8 is not an existing employee. We don't have any employee whose ID is 8. So this data is incorrect. However, the database did not prevent this from happening because I do not have any link between the lead column in the project table and the ID column in the employees table. This link is what we refer to as the foreign key. So in order to enforce that, I need to define a foreign key on the lead column and say that this is referring to the ID column in the employees table. What does it mean to have a foreign key? It means that every value in the lead column has to be one of the values existing in the source, in the ID column in the employees table. I cannot add the row that I just added right now if the foreign key was already defined. So foreign key helps in enforcing something that we call referential integrity. Referential integrity means that when we're referring to something, that something must exist. We cannot refer to something that does not exist. So if you are referring to an employee, that employee must exist. You cannot refer to employee number 8 when you don't have an employee with ID equals to 8. Foreign keys usually point to a candidate key in the source table. In most cases, they point to the primary key, but you could potentially have them point to a different candidate key. The important thing is that they have to point to something that is unique. So in our example here, we are pointing to the ID column, which is the primary key. The foreign key matches whatever that is pointing to in terms of the number of attributes. So if the primary key in the employees table had 2 attributes, then the foreign key from the projects table will have 2 attributes, and so on. So if the primary key that's pointing to is, simple or composite, then the foreign key would also be simple or composite correspondingly. Another thing that the foreign key would help prevent, again, suppose that this is our tables, the incorrect row has been removed. Now, suppose that I want to remove this employee. Employee number 4, John, I'm going to remove it from the employees table. If I do that, this will mean that this project number 1, which is referring to John, once I delete John, then this project is going to be pointing at something that does not exist, which cannot happen according to the foreign key. So the foreign key will prevent me from deleting that row. It will tell me that, okay, wait, there is something referring to that, you cannot delete it. So the options that I have is either I delete that project first and then delete John, or maybe I can reassign that project to someone else and then delete John, and so on. The default behavior when you're trying to delete something that has something pointing at it is that the system will disallow it. There are other ways that you can explicitly define. You can tell the system, hey, if I ever try to delete something like this, automatically delete anything that's pointing at it. Or automatically replace that value, like 4 in the project table, replace it with null. So anything that's pointing at something that gets deleted, it's going to become null. So there are ways where you can tell the system to do one of these things, but the default would be for the system to prevent that operation. I will not get into how to specify those things, but you can look it up. Okay, let's demonstrate again in Postgres. So here is the employee table that we were just working with. Again, this is the data that we have there. And then we also have the projects table. So this is the table definition. It has just 2 attributes, name and lead. So this is the project name and the lead employee. And this is the data that we have in that table. We have 3 projects here, and those are the lead employees for each project. Now, suppose that I want to insert a new project, project 4, and I'm going to say the lead here is employee 8. This was inserted successfully. And to confirm, there we have it in there. Problem with that is we do not have an employee with ID 8. So this is referring to something that does not exist. Why was this allowed to happen? Because we do not have any linkage between this lead column here and the ID column in employee, which is the foreign key that we just talked about. So we don't have a foreign key defined right now. So to prevent us from making a mistake like this, we need to define that foreign key. How do we define that? Again, using the alter table statement. So I could say something like this: alter table project, add foreign key on the lead column, and this references employee, the ID column. Of course, this will not work right now because we have a value that is not referring to an existing employee. So it says here that lead equals 8 is not present in the employee table. So again, before adding a constraint, you need to fix the data so that the constraint is satisfied. So I will remove that new project that I added. So I removed it. Now we can reapply the constraint again. So now we have that foreign key defined, and let's confirm by checking the table definition. So here's the table definition, and now we have a foreign key constraint on this column, which references the ID column in the employee table. So if I try to reinsert that data, it should not let me do it. So we have an error here. We're violating the foreign key constraint because this value is not present in the table employee. So this is what the foreign key can help us with. We can also try something else. We have these 3 projects with those 3 leads, right? So let's say we try to delete, not from the project table, but we want to delete John, number 4, from the employee table. Given that John is leading a project, would it allow us to do that? So if we are successful in deleting John from here, then this project will become referring to something that doesn't exist. So that should be a problem. The foreign key will not allow us to do this. So if I try to do delete from employee, where ID equals 4, it cannot. Again, this will violate the foreign key constraint because ID equal 4 is referenced from table project. So in order to do that, I need to remove first the project that refers to employee number 4, and then I would be able to delete that employee. All right, so to summarize what we talked about today, we talked about the different kinds of keys that we might see in a database system, specifically in a relational database. We started with superkeys, being any combination of attributes that can uniquely identify a row in the table. We also talked about how these superkeys may have additional information. So we talked about the minimal superkeys or the candidate keys. And then from these candidate keys, we are able to select the primary key. Any other candidate keys that are not the primary key are the alternate keys. We also talked about how the primary key can either be a surrogate key or a natural key. We also seen foreign keys that enforce this referential integrity between different tables. And last but not least, we know that any of these keys can either be a simple key, which means that it has one attribute, or it can be a composite key, which means that it has multiple attributes. Hopefully that cleared the confusion and made these terms more clear. If there are still any questions or if there's something that requires more clarification, please let me know in the comments. Otherwise, please like and share the video and subscribe to the channel to get all the updates. And with that, thank you so much for watching, and I will see you in the next video.